Welcome. In this video we are going to derive Einstein coefficients for a two-level system. So what is a two-level system? Let's talk about it. So let's say we have two levels, level 2, level 1. The level 1 is at energy E1, level 2 is at energy E2. So the atom can be at any level, either in the level 1 or the level 2. By this I mean to say that the atom can be excited or in the ground state, right? So when the atom is in the ground state, not the ground state, when the atom is in excited state, it can spontaneously go to the ground state by emitting some energy that will be equal to h cut omega. But when it is in the ground state and it has to go to the level 2 from the level 1, it has to absorb some energy equals to h cut omega. Similarly, there can be another process that is termed as the stimulated emission, and in the stimulated emission atom goes from the higher level to the lower level by absorbing some energy h cut omega and emitting the energy of same phase. So it will have the omega of the same omega, right? So this first is spontaneous emission, the second one is absorption, and the third one is stimulated emission. So we have these three phenomena that are happening in a two-level system, and in the general case, let me just draw it here, that we have N2 atoms in the level 2, N1 atoms in the level 1, E2 energy of the level 2 and E1 energy of the level 1. So how many processes are happening there? There are happening three processes: absorption, spontaneous emission, stimulated emission. And we can write equations corresponding to these three phenomena. So for the first one, that is spontaneous emission, we can write the change in the number of atoms in the level 2 with respect to time, and it will be equal to minus a 21 N2, because the number of atoms in the level 2 are decreasing. That's why we have a minus sign here. And for the absorption, since absorption is related to absorbing some energy of some frequency omega, we will be writing dn1 over dt equals minus b12 omega n1, because the number of atoms in the level 1 are changing and it is decreasing. That's why we have a minus sign here. But here we have an additive term, that is u of omega, that is the total spectral energy density available in this system, from which the energy of certain frequency is absorbed to make transition from level 1 to level 2. Similarly, we can write equation for our third process, that is the stimulated emission. And stimulated emission, and for this process atom goes from N2 to N1, so that's why we have the rate of changing the number of atoms in the N2, and it will be equal to minus B21 omega N2, and here we have again the total spectral energy density available. So we have these three equations corresponding to our three phenomena happening in the two-level system. Apart from these three phenomena, what happens there is that uh, what happens here is that the so instead of what happens here is that we can talk about uh, it another way, about how the Einstein think of it. So Einstein thought of it as a box, right? So in the box it has some atoms. So these atoms can be in the excited state or in the ground state. So the excited state atoms will be making transitions from the higher level to the lower levels by spontaneous emission and by the stimulated emission, and the atoms from the lower level will be making transitions to the higher level by absorbing some energy of h cut omega. But there will be a time in these when these three transitions will be happening, there will be a time when the thermal equilibrium will be achieved. So in the thermal equilibrium, the upward transitions due to absorption of the energy will be equal to the downward transitions that are spontaneous and stimulated. So by following this Einstein analysis, we can quickly write that absorption, that is the absorption, will be equal to spontaneous emission plus stimulated emission. So actually these are rates of absorption and spontaneous and stimulated emission, so these are not just anything else. So we have already written down the equations for the rates, so we can write, so we can write minus b21 omega n1 u of omega, it will be equal to minus a21 n2 plus, no sorry, not plus, it will be minus b21 omega n2 u of omega, and we can multiply this equation with minus sign to make it positive. So this is the equation we get from Einstein analysis. That's how Einstein thought of it, that the upward transitions will be equal to the downward transitions. So since we are saying that the body, this box is in thermal equilibrium after some time, so we are actually entering the domain of thermal and statistical physics, and in the statistical physics we have two very famous phenomena. The one is the Boltzman law, and the Boltzman law says that the ratio of atoms in N2 to N1 will be equal to G2 to G1 exponential minus h cut omega over kBt, where G2 is the degeneracy of the level 2 and G1 is the degeneracy of the level 1. So we have from Boltzmann law. The other from the other law, that is we have Planck's distribution for the spectral energy density, and we have U of omega equals h cut omega cube over pi square c cube 1 over exponential h cut omega over kBt minus 1. So we have these two famous relations, and we will try to make sense of the Einstein analysis with these relations, right? So let's just try to do that. From the Einstein analysis we can write b21 B21 omega N1 minus, okay, so I have made a mistake I guess here. It is B12, so it is B12 here. So B12 N1 minus B21 omega N2, and if we take the spectral energy density common, it will be equal to A21 N2. Further, what we can do is we can write U of omega equals A21 N2 divided by B12 omega N1 minus B21 omega N2. So if we take this B21 N2 common, we can write U of omega equals A21 N2 divided by B21 N2, and here we have B12 omega N1 over B21 omega N2, and we have minus 1. This N2 will cancel out with this N2, and we are left with A21 over B21. So we have one term here and we have the other term here. If we look closely, this spectral energy density corresponds to this spectral energy density, and this A2 over A21 over B21 will be equal to this constant, and the other highlighted term, this one, will be equal to this term. So by comparison we can write A21 over, so here we have omega as well, so A21 over B21 omega will be equal to h cut omega cube upon pi square c cube, and other one we have B12 omega N1 over B21 omega N2 equals exponential h cut omega over kBt. So we can simplify this. A21 will be equal to h cut omega cube over pi square c cube B21 omega, and on the other hand we will have B12 omega equals B21 N2 over N1 exponential h cut omega over kBt. Right, here we have N2 over N1, and we can just put its value. B12 omega will be equal to B21 omega, here we have omega as well, it will be equal to G2 over G1 exponential minus h cut omega over kBt times exponential h cut omega over kBt. This will be equal to 1, and we will be left with B12 omega equals B21 omega G2, and we can multiply G1 here. So this is our second equation. So these were the relations that Einstein found for after his analysis for a two-level system. So we got A21 equals h cut omega cube over pi square c cube B21 omega, and B21 omega G2 will be equal to G1 B12 omega. For the same degeneracies G1 equals G2, we will be having B21 equals B12, and then we can quickly find out A21 from that. So this is the Einstein analysis, and these are the Einstein coefficients A and B for a two-level system. So that's all.